Welcome, everybody, to tonight's webinar. Tonight we have Robert Torbin, who's Director of Codes and Standards with OmegaFlex, and he is going to talk today about inspecting CSST gas piping in homes, and I'll turn it over to Robert at this point.
Thank you very much, and good evening to everybody on the webinar. As was stated, I am the Director of Codes and Standards for OmegaFlex, but we will be talking specifically about CSST as a generic product. CSST has become very popular in the plumbing industry and has been used in the United States for over 30 years now, and there's 1.5 billion with a B billion feet installed and counting. It has become the dominant piping of choice for residential markets. And so, as we'll discuss, you'll be seeing this in present and future inspections without a doubt. There are 5 U.S. suppliers of CSST. And I'll just spill the names out. But again, it's not going to be really critical for you to know the brand because the installation requirements are all the same, with the exception of how you assemble the fittings. It really makes no difference which brand you're looking at. But the 5 brands, what I call the big 3, are WardFlex, Gas Tight, which makes flash shield, OmegaFlex, which makes track pipe. We all make the product here in the United States, so it's U.S.-based manufacturing. The 2 other brands, ProFlex and HomeFlex, are actually imported into the U.S. From Asia, and they are made to the same national standard that the big 3 use, but the companies, HomeFlex and ProFlex, don't support the product in the same way that the U.S. manufacturers support the product. We'll talk about that during the webinar. And again, keep in mind that you guys, home inspectors, are not expected to enforce the code, but it is very useful to know the code and to recognize that the installation of gas piping, whether it's steel, copper, or CSST, the code requirements represent the minimum. As with all codes, whether it's the fire code, the electrical code, the residential code, it represents the minimum requirements. Now, minimum is not meant to mean inferior. It's that the code officials have determined what is a safe and reliable structure, and they write the code around that. There are ample factors of safety in everything that we do within the code, but again, it dictates what has to happen as a minimum. And of course, the manufacturers of CSST have their own instructions, and in some cases, the manufacturers have more rigorous installation practices that may be covered by the code. And so what we'll talk about during the webinar today is, the generally accepted installation practices, whether they are above the or at the minimum code. We'll talk about the way the manufacturers want their product installed and what you are typically going to see in any type of residential inspection, and based on the manufacturer's instructions. And that's partly due to the fact that the country as a whole, and I service North America, so I include Canada, but here in the United States, we don't have one code for fuel gas installations that is followed in all 50 states. We actually have 50 fuel gas codes because, in essence, each state adopts their own fuel gas code based on one of the 3 model fuel gas codes, and then they amend it. And then some keep up to date, some are behind. And so there is, again, a sort of a default is to the manufacturer's instructions. Now, the thing that differentiates CSST compared to steel pipe or copper pipe is that it's listed to a national standard, LC1, that is performance-based. In other words, the standard really says how the product has to perform rather than prescriptive design requirements. And what happens is that all 5 products have different corrugating tubing or corrugations in their profiles because the standard doesn't have a prescriptive geometry. So in that regard, although we treat these products generically, each manufacturer's brand is, within its own self, consistently and non-interchangeable with other brands. So the fittings from my product, Track Pipe, won't fit on AwardFlex tubing. And even though we all comply with the same standard, we're allowed to have different profiles. And again, CSST stands for corrugated stainless steel tubing. It's made out of 304 stainless steel, highly corrosion resistant. We use, and I say we, I'm talking collectively as an industry, use brass fittings. And as part of the standard, we're required to sell the entire system. And that's why, when you look at track pipe, it'll be track pipe tubing, track pipe fittings, track pipe listed strike protection, and our own installation instructions. But as I had previously stated, everybody pretty much has the same requirements in terms of installation and sizing and electrical protection. The big advantage of CSST, of course, is that it comes in large spools, comes in long lengths, and you're able to string it out like Romex wiring. In fact, I call it the Romex of gas piping. And we can eliminate or minimize the number of joints between the point of delivery and the appliance. So that's the big difference. Now, it also comes in 2 flavors. We have chocolate and vanilla. We have the standard yellow jacket, and we have the more recent arc-resistant black jacket. And the color of the jacket, notwithstanding how pretty it may look or how easily recognizable it may be, is primarily just a covering for the tubing to protect it against the weather. And in the case of the black jacket, it's meant as an arc-resistant barrier. So it has electrical protection features, which we will discuss later. All CSST has markings on it, and it's dictated by the standard. And as you can see on the left there, you're going to find the brand or the manufacturer's logo. There'll be a model number, and then there'll be the logos of the various inspection certification agencies that examine and list our piping. So we, as an industry, submit our new products to the Canadian Standards Association, or CSA group, and they do the testing and they do the basic listing of the product. Now, LC1, the national standard, is the only standard that's recognized by the fuel gas codes. So any other kind of CSST that's not listed to LC1 should not be acceptable as gas piping. We also get inspected and or certified by ICC Evaluation Services, Uniform Plumbing Code, or IAPMO, and in some cases, UL will have their marking on there because we do fire testing on the jackets and on the joints. So all the same markings. And then again, later on the tubing in somewhat smaller font is the tubing size, the rated pressure, and typically CSST is rated for up to 25 PSI. And there's some signage on there to mention that it's fuel gas and that it's non-combustible or fuel gas. Or on the black, The only difference in the marking, as you can see there in the middle of the picture on the right, is the letters AR, and that stands for arc resistant. So although the corrugated tubing and the fittings are the same, whether it's a yellow jacket or a black jacket, the black jacket goes through several other electrical testing to demonstrate that the jacket will provide a barrier against arcing that may be due to lightning, for instance. And so the AR is an important note that you should do as inspectors. So these markings, which you should look for in case the tubing is visible to you, typically you'll see it in a crawl space, in an attic, in a garage, in a basement. But where you can't see it, I think it would be important that you take notes about, that these markings exist, and making sure that they're consistent with the requirements in LC1 so that this is a listed CSST product. And if it's black, you should find that designation AR to make sure it's arc resistant. As we'll discuss later, there will be some differences in the electrical protection requirements for the black product. Now, there are a case where some manufacturer could actually make a black jacket that is not arc resistant. Of the products on the market today, the indoor black jackets are all tested for arc resistant. But, we could get a manufacturer from China bringing their product into the US, and it's just a black jacket because the code allows you to have either yellow or black, but it's not necessarily required to be tested as arc resistant. So that's why I recommend that during your early inspections, when you come across gas piping, that you do take the opportunity to note the markings and the critical markings in terms of the listings and in terms of this AR marking. Fittings, as I mentioned earlier, are not interchangeable between brands. However, as you can see in the picture in the upper left, we have two sets of threads on each fitting. We have on the piping end NPT tapered pipe threads, and that has to be sealed with tape or dope. And that is a universal tapered pipe thread that you could put into valves, into regulators, into other steel pipe components, couplings. We use manifolds. On the tubing side, these are straight threads, and they're there to obviously screw the cap of the fitting together, but also allows us to get mechanical leverage so that we can squeeze the end of the tubing into the fitting and creating a metal-to-metal seal. Now, this is something you're not going to see because the fittings are all together, but you should be able to see some level of indication that there's pipe dope or tape on the piping side where it screws into a malleable fitting or a manifold, so that the pipe was properly put together. If, on the other hand, you observe pipe dope and or Teflon tape on the tubing side, you probably could note that maybe the fitting wasn't properly put together because there should be no extra requirements for sealing the threads on the tubing side of the fitting. We're going to talk about exposed stainless steel in a minute, but depending on the brand and depending on the fitting design, the jacket has to be removed in order to put the fitting onto the tubing. And in the more current editions of these products, like in the lower left, if the fitting is properly assembled, there'll be no exposed stainless steel. If the older fittings, there was always 1 to 2 inches of exposed stainless steel, and that's fine. But we'll talk about that later in the webinar. As you can also see in that middle picture, we can interconnect different brands by using a common pipe coupling. So in some homes, there may be repairs that were done in older homes where you might actually have two brands of CSST in the same house. So that's going to be perfectly legal. The code doesn't treat CSST by brand, but rather by generic commodity product, much like steel pipe or copper pipe. And so it is permissible to intermingle different brands in the same house as long as they're properly interconnected. And you can see in the upper right-hand corner, sometimes there's damage to tubing, and we have these standard tubing couplings within each manufacturer's inventory of fittings. They may have couplings. And in some cases, you may be fixing or repairing or modifying an existing home with yellow with black tubing. And we'll talk about the implications of that. And finally, in the center bottom, these fittings are designed for concealed locations. However, very typically in your work, you're not going to see any fittings behind the wall, nor is it your obligation to identify fittings behind the wall. But in some cases, you might note that fittings are either partially or permanently inside concealed locations, and that's perfectly acceptable. That doesn't create any hazard or any code conflicts. But just so you know, the fittings can be used in concealed locations. Now, CSST looks like, smells like, but is not exactly like flexible appliance connectors. Some appliance connectors have yellow jacket and they have mechanical fittings. And if you look quickly, you'll say, oh, that's yellow CSST. But they are made to different standards. The convolutions are what we call helical in shape, not annular, which means it's one continuous loop. Whereas CSST, each convolution is distinctly separate from the adjacent convolution. And flex connectors should not be treated like CSST. They're considered an accessory, but they're easily confused. And in some cases, when you're doing your investigations, some homeowners looking to avoid hiring a plumber to do a repair might actually go to the Home Depot and buy a flex connector and use it to repair a pipe somewhere in the house or to extend a piping. But flex connectors are not considered piping. The longest length for a flexible appliance connector is 6 feet. And if they want to make up 10 feet and they try to put two flex connectors together, I mean, you can do it physically, but in your inspections, this would be one of the times when you would say, oh, you're in a code violation, because flexible connectors should not be used as piping, and it should be removed and replaced with, regular, I use that word, regular CSST or steel pipe or copper, as the case may be. So typically you're going to see flex connectors only at the appliance connection from the end of the piping system. The code defines the piping system as all the pipe from the discharge of the gas meter or the second stage regulator for propane all the way through the house up to the shutoff valve for each and every appliance. So each and every gas appliance has an upstream shutoff, and officially the piping system ends at the valve. And flex connectors should only be located downstream of that shutoff valve and into the appliance. Now, again, I mentioned that the manufacturers all have design and installation manuals. It's part of our listed system. And they pretty much all say the same thing in terms of sizing and routing and mechanical protection and electrical protection, inspection and repair. But if you do know the brand, you can go to the manufacturer's website and download their design and installation manual. Or go and get one from each of the 5 manufacturers and have it in your truck. Or you can get the digital version and keep it on your laptop or your tablet. Or in some cases, we even have design and installation manuals for iPhone and Android phone apps. So no matter what level of electronics or paper that you like, you can have a copy of the design and installation manual. And again, unless you're doing installation work yourself, the only reason to really have all the manuals is because you actually need to know about the fittings and or the sizing tables. But otherwise, the installation instructions will be pretty much consistent with the latest edition of the fuel gas code, the ICC International Fuel Gas Code, the IAPMO Uniform Plumbing Code, or the NFPA 54. The problem is that houses get built earlier. They're on older editions of the code, and you as a home inspector are not expected to keep track of which codes that are being enforced today based on the codes that may have been enforced at the time the house was built. Now, CSST, as I stated, is the Romex of gas piping, and therefore you could find CSST anywhere in the house because it's easy to pull and easy to thread through the structural members, whether it's in the floor or in the walls. So typically you're going to come in from below. It could be in a crawl space. It could be in a full basement. It could be under a slab. Going to go up into the walls, depending on how many stories in the house. It could be between the floors. It could be run all the way up to the attic space and back down to the second floor. It could be in the garage. Some cases it's run outdoors below grade, and sometimes it's run outdoors above grade, and even for commercial buildings on the rooftop. So as an inspector, as you walk through the house, you should not be surprised if in the attic there's gas piping, in the basement there's gas piping, outdoors there's gas piping. And each and every time that you see it, again, you could look for the markings, you could make sure on the color and the brand, and then we'll talk about whether or not it's properly installed.
Bob,
Yes.
question: any special requirements below grade through block poured concrete walls?
Yes.
Is it can it be just flopping around up in the attics? You go up in the attics, we see the stuff. It just run across the top of the joist. What are some of the requirements?
All right. Well, let me just talk about the underground through the foundation wall first, and then as I get further into the webinar, we'll come across issues with inside the house. But CSST can be run underground. So like the main service line coming from the gas supplier or from an LP container typically has to terminate at a meter. And the meters or the second stage regulators are today, in today's code, always outside above grade. And so piping going into the house will always go in above grade. In older homes, where I grew up in Massachusetts, in the older buildings, the meters are on the inside of the building, and they're going to run their service line below grade through the foundation wall. That practice is pretty much stopped in current construction. But every now and then, you're running CSST from the inside of the house and you want to run it outdoors to a barbecue or something, and you want to penetrate the foundation wall. So two things to note. Anytime you penetrate concrete, CSST has to be installed through a sleeve, typically a plastic sleeve. So the CSST doesn't come in direct contact with the concrete or cinder blocks, whatever the foundation may be made out of, bricks, whatever. So anytime we penetrate masonry construction, we're going to sleeve the CSST and we're going to seal the gap between the tubing and the sleeve. If we penetrate below ground, same thing applies. Again, the penetration of the foundation wall below grade is sort of frowned upon by current code, but in an older code, there may be older requirements prevail. So anytime we penetrate the foundation wall above or below, we have to seal against weather, insects, and debris coming into the house. And then we'll talk about attic spaces and inside walls as I get into the seminar. But let's
So
turn
it
our
can be
attention.
placed underground outside once it exits the wall. You could
Say again?
You can run it underground without protection. Without protection.
So outdoors, let's just talk about that quickly. Outdoors above grade, if you're between the level of grade and 6 feet of elevation, CSST has to be protected in some type of conduit, clamp over like a rain gutter, or like they use for a refrigeration line, some type of clamshell. We want to protect it against physical damage. If you're running it underground, CSST has to be also run through watertight plastic conduit. Now, OmegaFlex makes a product which is called PS2, which again has markings on it, but it's unique within the CSST world, where the jacket is designed to act as a conduit. That particular product could be directly buried underground without an additional conduit, but it's the only product in the industry right now that doesn't require some type of protection for underground installations.
Thank you.
Okay. So I want you to look at this page here. And in fact, for those of you at home who have cell phones, you should take a picture of this page. And I'm sure we can have this whole presentation provided, or at least this page provided. But in some states, these 5 states in particular, we've actually changed the home inspector rules to require that you, the home inspector, have to alert your client, whether it's the buyer or the seller, that you've seen CSST in the premises and that it needs to be further inspected for compliance with the electrical bonding requirements as determined by an electrical contractor. So we tell home inspectors to put this paragraph in all their reports if they see CSST in the house. Okay, and whether it's yellow or black. All right, I know it says yellow, and I'll explain why later, but if you're doing your inspection and in the course of your inspection you observe CSST, this little footnote is sort of your get out of jail free card, because basically the responsibility for ensuring that the CSST is properly bonded to protect it against lightning threats and in accordance with the manufacturer's instructions is the plumber who installed it, and or the buyer, and or the seller, not you. But you need to let them know that you've observed it, that you weren't able to necessarily confirm that it was properly bonded. I mean, it may be something you're not qualified to inspect, and that piece of the inspection is required to be done by a licensed electrical contractor in order to confirm compliance with either the local code or the manufacturer's instructions. And you'll see why as we go through the next few slides. You'll understand that electrical protection gets pretty complicated, even though it's a relatively straightforward activity, because the codes are not consistently up to date in all 50 states. Not all manufacturers make yellow and black CSST. Some just make yellow, some just make black. And the codes have been continued to be changed and updated, including the upcoming 2024 code. So starting in 2009, we've been changing the fuel gas code for CSST bonding requirements in 9 and 12, 15, 18, 21, and now 24. So it's a moving target. So here's the first sort of giveaway. It's the age of the house. All right. And, you may or may not know when the house was built, but you can obviously tell by looking at it. If it predates 1990, CSST was not even in the marketplace prior to 1990. So many of these older houses will be steel pipe. But that's certainly something to note, that if the house has gas and the house really hasn't been updated since it was built, it's probably no CSST in the house. However, CSST lends itself to remodeling projects. It's really good for adding new gas loads into existing houses. So if the house was old, it still may have CSST installed. In 2003, the electrical code was changed. So in newer homes, they're less likely to have gas piping that's bonded than in older homes. In older homes, uh, electrical bonding was mandatory on all gas piping systems, steel, copper, and for those early years, CSST. But the electrical code changed their requirements for electrical protection on gas piping in 2003, which really opened the door to some of the problems that we currently associate with CSST and lightning strikes. So in newer homes, it becomes much more critical to look for the CSST, and if you're possibly can make a determination as to whether or not it's bonded up to current code. And then again, in 2007, black CSST was introduced, and that has different set of bonding requirements than yellow. And those rules were changed in 2009 when we started institutionalizing what had previously been manufacturer's instructions. So starting in 2009 and going forward, any new house with CSST, there is for sure some requirements for bonding and protecting CSST from lightning arcs. So just keep that in mind.
That's all of it, right? That's black, the yellow, everything. Because I've heard some people say, "Oh, you don't need to bond the black CST."
Yes. So well, the part to that comment, the answer is yes and no, and the reason for is that in the early days, starting in 2009, it didn't matter. All CSST got bonded. Then in the 2018 code, which a lot of states are just now using, there was a differentiation between yellow and black. As long as the black had a pathway to ground, like through the equipment grounding conductor or the third wire, you didn't need to add the additional number 6. But yellow always requires the number 6. So if you look at a new house, relatively new, built in 2018, it still may be under the old code requirements of bonding both black and yellow. And then starting in 2018, some states are just now adopting the 2021 code. But starting in 2018, houses built under those codes have different requirements. And although it sounds like you don't need the bonding, you actually do. You need the minimum bonding with black. You just don't need the extra big conductor, the number 6 conductor, provided the black has a electrical connection that gives it a pathway to ground. And this is why for home inspectors, it's nice to know all this stuff. But, a word of caution is that don't try to be the lightning doctor here. It's a very complicated and it's a very ugly quagmire to get yourself caught in. So the best thing to do is follow my advice and put that little note on your report. It says, I observed both black or yellow CSST, and you should have it checked out by a licensed electrician. Unless you can absolutely confirm that the bonding's been done properly, it may be something or a liability you don't really need to put on your shoulders.
Hey, Robert, we do have one question.
Yep.
Eric asked, what is the puncture resistance for CSST against sheetrock screws and etc.?
Okay, well, I have another slide up ahead. Well, actually, I don't, but here's the answer. We make listed strike protection. Now, This is beyond your scope because all our strike protections are put in place when the tubing is installed. And tubing that is properly installed in the middle of a stud bay would not be stapled to the stud bay or the stud in the stud bay. We want it loose and flopping in the wall. So it should be run mid stud bay. And where it goes through the floor or the ceiling, we have mechanical strike protection that are puncture resistant. They're tested and listed as puncture resistant from screw guns, pneumatic nailing guns, and etc. But you can't see it because it's behind the sheetrock. So it's not part of your inspection. But if they go out and they bought standard strike protection for plumbing, the galvanized plates, this is not adequate, does not meet the requirements of the national standard LC1 and would be in violation of the code. But again, that's beyond your inspection. It's the responsibility of the plumbing inspector to make sure those plates are in place while they're doing the rough plumbing inspection.
Now, with a lot of remodels and stuff, you know, it's not new construction. They may do it without a permit. How do you strap that pipe when it's running across the ceiling of an attic, or you see it in the garage? What's the strapping as per manufacturer?
Well, typically you would use the same kind of strapping for CSST that you would use for steel pipe. So you have this perforated strapping that you can use. You can use metal C clips. There's a whole variety of clamps and clips that you can buy at the plumbing supply house that you would use for copper and or steel pipe. So if you're running CSST up in an attic space, we typically want it out of harm's way. So we want it clipped to the bottom of the roof rafters. However, you know, some people will just lay it over in an unfinished attic. There's no harm in running it across the top of the ceiling rafters and just clipping it every other floor joist just so it doesn't move out of the way. And when you're between walls, we don't want any clipping at all. When you're in a crawl space or a basement, we want to clip below the floor joist, or it could be run through the center of the floor joist through drilled holes. The same way you would run water piping and or electrical, you can run CSST in the same way that you support water piping or heavy steel pipe, you would support CSST. Anything else is out of compliance with the code in the manufacturer's instructions. So just having it looped around, hanging in the air is in violation of the manufacturer's instructions in the code. Okay. Now just looking at this slide, so all yellow CSST starting in 2006 has to be bonded with a number 6 conductor. And we've changed the rules over the years as to where the bonding clamp needs to be located. If a new house today, the clamp could be almost anywhere between the point of delivery and the appliance. In some of the older homes and the earlier versions of the bonding requirements, the clamp would be at the meter. It could be somewhere upstream of the first piece of corrugated tubing. I would put it this way, you know, if you're looking at it and you can find the clamp, it actually doesn't matter where it is because all the locations are known to work. Even though there may have been restrictions in earlier codes, none of those restrictions apply today. So as long as it's downstream of the meter and downstream of the second stage regulator and somewhere on the piping system, but not mounted on the CSST itself, but on a malleable fitting or a manifold or a piece of steel pipe, all the way up to and including the drip leg at the appliance, all you need is one clamp per piping system, right? We don't need multiple clamps, even if we have multiple piping runs. So one clamp per house, located anywhere within the premises, indoors, outdoors, but downstream of the meter. It's required on all new construction, but if somebody adds CSST to an existing house, it should be brought up to current requirements. So if they use yellow to add a barbecue in an otherwise all steel pipe house, you would have to have a bonding clamp. And the bonding wire has to be at least a number 6. And it's going to run back to the grounding system. And I'll show you where those connections will be in an upcoming slide. But the conductor should not be any longer than 75 feet. There's no way you're going to be able to measure this conductor typically in one of your home inspectors, because it's going to be typically up in the ceiling or behind the wall. But again, on new construction, the bonding conductor has to be no more than 75 feet long. If it's black CSST, we don't need this number 6 conductor as long as we have some pathway to ground. And typically that pathway to ground is through a gas appliance that has a branch circuit, like a furnace, a boiler. Even most of these tankless water heaters have electrical power, your range oven, your clothes dryer. If they have a branch circuit, that branch circuit's going to have what's called the equipment grounding conductor. And that's going to provide a pathway to ground in case of a lightning strike and arcing occurs to both yellow and black CSST. The yellow CSST needs a more robust pathway to ground. The black CSST, the black jacket, does a lot of the heavy lifting. It reduces a lot of the lightning arc energy, but it doesn't eliminate it. And that's why we look for a pathway to ground. Now, again, this is beyond your responsibility, but if you want to know, what you need to advise your customer, well, if you can identify that it's black CSST and you can identify that one of the gas appliances has a branch circuit, then it's good to go. That meets the minimum requirements of the code today. It may not have been true 10 years ago, but today, if that house was upgraded, that would suffice, and it meets the code requirements. So either way, yellow will always require a number 6. Black may not necessarily need a number 6, but needs a pathway to ground. So this is what you're going to see on site, right? You may have a gas meter, you may have a second regulator. And so you're going to have a bonding clamp that's mounted on the pipe, and you're going to have a number 6 conductor, and that conductor is going to be routed through the house back to the service enclosure or to one of the grounding electrodes. In a multifamily, in this case, a picture on the right is a duplex where they have 2 gas supplies. The bonding conductor is allowed to be daisy chained across the 2 supply, and only 1 bonding conductor for the building. Could be in a crawl space, it could be on a steel pipe, and that would be the location if the house was built in 2009, 2015. It can be mounted on the fitting for the CSST, not on the tubing itself, but on the brass fitting somewhere, again, downstream of the meter. It can be at some midpoint at a manifold. We typically use manifolds with CSST because they like decentralized distribution. It can be all the way at the appliance. We're looking for a place in the house to put the clamp that allows us to keep the bonding conductor as short as practical. All right, it never goes on the tubing and never goes on the jacket because the clamps are not listed for mounting on anything but round pipe or hex head fittings, brass fittings. So if you see the clamp, and it could be on a black jacket and or the yellow jacket, but never on the tubing, it's a mistake, should be noted to your client. So where it connects into the electrical service, it can be at the panel box in the neutral or grounding bus. It can be directly to one of the grounding electrodes if it's outside, and or the rebar, like a UFA ground that might have rebar poking out of the floor in the garage. Or it can be bonded right to the grounding electrode conductor, the big cable that goes from the box to the grounding electrode system. So again, the picture on the left, we're bonding the little green wire is connected to the grounding electrode conductor. The middle picture is we're bonding directly to the grounding electrode, the rod. And or in the picture on the right, we're actually bonding to the copper water pipe, which in older homes was commonly used as the grounding system. So if you know that the copper water service was used or is being used for grounding, bonding the gas piping to the copper water service is perfectly acceptable. And again, I mentioned about U for grounds. You know, we get rebar coming out of the ground, out of the footers. Typically, the rebar in the footers or the slab is bonded together, and then one rebar is routed up into a visible place where the bonding clamp can be mounted. And for bonding clamps that are going to be behind the wall, there should be an access panel for you to open and inspect if you choose to do so. But as you can see here, we have the CSST on the right. The yellow CSST is coming off the steel pipe from the meter, and we run a copper bonding wire behind the wall board over to the rebar. That's going to be sheetrock. So there's no way you could examine or see the size of that bonding conductor or know, you know, you got the right clamp mounted on the right thing. But somewhere in that house, you're going to see that they use yellow CSST. And again, your responsibility to the buyer and your client is to let them know that it may need additional bonding, because in this house, you wouldn't have been able to confirm that proper bonding had been done. So it could be different size bonding conductors that you might observe, not only copper, but aluminum, single strand or multi-strand. These are all permitted by the electrical code. And just again, some things not to do, you know, if the bonding conductor and the CSST are run to the discharge of the meter, having it unsupported, both the CSST and the bonding conductor are in violation of both the electrical code and the fuel gas code. So, you know, CSST allows people to do wild and crazy things, but there still are requirements in the code for protecting and supporting both the bonding conductor and the CSST piping itself. Here's a typical example that you might observe in the field. A plumber wants to save time, so instead of running his bonding conductor back to the panel, he drives a special electrode right at the gas meter. And then in this particular case, his bonding wire goes to the wrong side. It's on the utility side. And the bonding conductor must always go to the customer side of the meter, and all grounding electrodes have to be bonded together. You cannot have and should not have a separate grounding system just for gas piping. It actually is a code violation in the electrical and the fuel gas code. We'll talk about a few remaining items in the time I have left, but we talked about routing, you know, and so the picture on the left, you know, CSST in an unfinished attic space could be just drooped along the roof or the ceiling rafters. But when it's commingled with other infrastructure, in this case, cabling, all these things get energized in a lightning strike and make it more likely that there'll be arcing between these pathways. So that yellow CSST would have been better installed if it had been clipped up against the bottom of the roof rafters. Now, that's something you can note to your clients as an improvement. But as far as meeting minimum code, it satisfies minimum code, but it's not the best practices of the CSST industry. The same thing with the picture on the right. You know, when CSST is run in areas where there are other electrical pathways to ground, be it communication cable, power cable, you know, security cables, they all have the chance of being energized in a lightning strike. And so we try to encourage people to run the tubing away from other metal objects in the building. But there's no requirement in the code that stipulates you shall avoid other pathways to ground. talk about clipping and supporting. So the picture on the left is typical of a full basement, but it could be a crawl space. And the tubings are run parallel and clipped along the bottom of every other floor joist. Now, we have a table in the code that, depending on the tubing size, the clips can be so many feet apart. It varies by diameter. But they should be clipped nonetheless, or they could run through the center of the floor joist without needing any clips. But they do require metal clips, not plastic clips, as you can see on the picture on the right. Inside exterior walls. Today, with the energy codes being what they are, they're putting more and more homes with 2x6 and spray foam. We don't want CSST inside spray foam walls, but you won't know that. It's behind the sheetrock. You may or may not know the routing of the CSST within the building until you get up in an attic space. And so, again, sometimes you learn these things as you go through a house, and you might note them on your research report, but it's very difficult in many cases in an old existing home to really know what's going on behind the wall. We do allow CSST to be put in walls with soft cellulosic or fiberglass insulation, but typically on interior walls, like the picture on the right, the tubing should be freely strung between the floor and the ceiling, not clipped like wiring to the side of the wall stud. So if anybody is deciding they're going to hang a shelf or a picture and/or decides to use their sheetrock gun and just have fun shooting nails into the wall, the tubing has a chance to flex and bend out of the way. But where it goes through the floor and through the ceiling, you note in that picture, we have mechanical strike protection. And those are going to be required when the wall is closed in and you're not able to determine that there's CSST behind the wall. We have manifold requirements. We have all kinds of manifolds. They're allowed to be fabricated on site. The picture on the left is, an example of what passes for current practices today, where they use press connect fittings like Viega Mega Press. We make cast manifolds like the picture on the right. They can be in the attic, they can be in the basement, they could be in garages. But typically, we treat the manifold like a big fitting. So if it was just a manifold, you don't necessarily going to find it on the outside of the wall. But as soon as there are valves and/or pressure regulators, the manifold has to be accessible for inspection. So if you're up in the attic space and you see a 2-pound regulator, that manifold has to be readily accessible for inspection and maintenance. And it should be secured to the structure in some shape or form with a bracket or in a box or something permanently installed against the structure. Appliance connections, CSST is treated like pipe. So if you have fixed appliances like furnaces and boilers, we typically terminate at the shutoff valve upstream of the appliance control valve. If it's a movable appliance, we typically will have, like you see in the picture here, we have a floor flange with a shutoff valve, and then we have a flex connector. Now that's going to a water heater, but let's just say that was a clothes dryer or a freestanding range oven, terminating the CSST with a floor or wall flange, and then making the final connection with a listed flex connector. CSST should never be connected to movable appliances in lieu of listed flex connectors. Picture on the right again shows a good install. We got the tubing up against the floor joists in the basement. We drop down and they transition to steel pipe. The picture on the left is in a multifamily unit where we have a water heater in a small closet. It's black CSST run at 2 pounds right to the water heater. Then the pressure is dropped and connected to the appliance at 7 inches. So these pressure regulators for 2-pound systems can be found many places in the house. You may or may not know that it's a 2-pound system. But if you see these line pressure regulators, it doesn't really change anything in terms of how the CSST is installed, other than regulators in manifolds, like this picture in the middle, have to be in readily accessible locations for inspection, maintenance, and repair. A lot of people use CSST. They're adding all kinds of new appliances or changing out like tankless water heaters. And a lot of times they'll run off a steel pipe system or use 2 pounds, because tankless water heaters, have a big demand, 200,000 BTUs. Same thing with power generators. They have a high demand, and they're trying to add it to an existing home. They run the line all the way back to the meter, run it out there at 2 pounds so they can use smaller pipe. You can either run it through the house or outdoors underground or outdoors above ground, depending on where the generator is being located. And in some climates, these tankless water heaters are in fact outdoors. So CSST can be run above ground, below ground, but needs to be protected when it's below 6 feet of elevation. Meter connections. Normally the gas piping supports the gas meter, but in houses where meters are independently supported by a bracket, which is indicated by the picture on the right, CSST can be run directly to the meter discharge. The picture on the left is just a multifamily. And again, if we talked earlier, note where we're going through the concrete construction. You can see in that picture, every run of CSSTs in a plastic sleeve. And what hasn't been done yet is that they haven't sealed the space between the tubing and the sleeve and between the sleeving and the wall. But again, very neat installation, fully supported, nice parallel runs. There's no real excuse for sloppy workmanship. However, in some cases, in some parts of the country, depending on who's doing the rough plumbing, it can be pretty ugly. So it's not necessarily against the code to be ugly. They've sort of taken workmanship out of the code. It's not something that you really could, signify to your client that there's a problem with the gas piping in CSST if it's kind of poorly installed. You might make a note that, it could use some additional support, but that, they should hire a licensed gas fitter or plumber to do that. Talk about outdoors again. The picture on the right is above ground, and that CSST is actually run inside a conduit along the side of the house. The picture on the left is, properly supported, but it's not protected. So the picture on the right is not in compliance with the manufacturer's instructions for protection between the grade and 6 feet of elevation. I would also argue that the run from the wall to the inlet of the I guess this looks like a heat pump or something out there, or a boiler, should also be supported, because its unsupported length exceeds requirements in the code for support. Outdoor. So when we have exposed stainless steel, in some hazardous environments, stainless steel will corrode. So if they remove a lot of jacket and it's installed outdoors, it needs to be wrapped, as you can see in the picture on the right, where it's connected to an outdoor meter. The picture on the left, let's just say it was in a laundry room where it might be exposed to chlorines and Clorox chemicals. It shouldn't be wrapped to protect it as well. In pool houses where they have chlorinators, it should be protected. In animal facilities, not that you're necessarily going to be inspecting barns, but people have animal coops on their property, and they sometimes have to be heated. So in livestock areas, exposed stainless steel should be protected by additional wrapping. And we make special silicone tape for this wrapping process. It shouldn't be Scotch tape or electrical tape, but it really needs to be manufacturer's recommendations. All right, so getting towards the end here, this is your checklist, at least the things where the CSST is accessible for inspection. Again, you need to make sure that if you see CSST, you say there's CSST. It's like the TSA people at the airport, see something, say something. So if you observe yellow or black CSST, you should have that little note that I referenced earlier in your report that it should be further evaluated for electrical protection by a licensed electrical contractor. You could identify the markings in terms of making sure that it's a listed CSST product and not some Chinese knockoff product that, you know, was bought for a different purpose. People have made corrugated tubing for decades. We've only been making CSST for fuel gas piping for 3 decades. And it is especially tested and listed for fuel gas. So people can and will install garden hose sometimes and try to use it for gas piping as well. So the certified bona fide CSST have these markings. You should identify the markings and basically confirm that it is a legit product. Again, because it's yellow or black, you should see this bonding clamp and wire. You don't necessarily need to re-engineer or confirm the engineering, but at least you could note that the CSST appears to be electrically protected because of the presence of the bonding clamp and the bonding wire, but you're not necessarily sure how it was connected. And again, based on your little footnote, you know, the buyer, your client should have additional inspections done if they're concerned. You know, the manifold should be in the accessible location, particularly those with elevated pressure. Appliance connections should be visible, should be made in accordance with the code, and CSST connections should never go directly to the appliance. We didn't talk about appliance vents. It's sort of beyond the scope for this particular talk. Evidence of corrosion. So if you see CSST outdoors and it's not wrapped, or in laundry rooms and it's not wrapped, and you notice that there's some surface discoloration of the surface, it may be evidence of corrosion, and it should be noted that the tubing should be covered in accordance with manufacturer's instructions. Now, again, you can get the manufacturer's instructions online free of charge. It doesn't necessarily have to be the brand you're inspecting. But again, because it's free and easy, you could have all 5 brands on your laptop and not worry about it. And then you can just pull up the right one once you've identified that there is CSST in the house. So with that, right at 5 o'clock or 8 o'clock, I guess I can stay online for as long as necessary to answer questions.
I think it was very, very thorough. The one thing I would say, we have somebody typing a question now, but a lot of what I hear when I'm doing an inspection is I will call out the CSST not being bonded, and then what I will get back from the electrician or the homeowner or the agent is that the home inspector doesn't know. The home inspector doesn't know what he's talking about. The gas pipe,
Yes.
the iron pipe coming in from the street is the bonding, is the grounding. And you don't need any additional grounding for CSST, because if there's a lightning strike,
Yeah.
it's that electricity is going to follow that path of the pipe into the ground.
Right.
That's what we hear.
Yeah, I know. All right. So let me answer your question, but let's just put this on the table. You know, I'm not opposed. When I do these kind of talks, particularly for plumbing inspectors, I talk for at least 2 hours. And I realized we sort of did the abbreviated sort of Cliff Notes version tonight. However, in the future, I'm more than happy to put on much more technically in-depth review of electrical requirements for gas piping in general. So let's just sort of put that on the table. But to your point, first of all, we're only talking, when we talk what you're doing, your home inspectors, we're only talking about what's inside the house. The gas line coming from the utility in a new home, and I say new, like in the last 20 years, any house built this century is going to have a plastic service line. So there's no bonding and grounding going on because the service line cannot act as a grounding means for the house piping. In the old days, I mentioned about copper, when there was copper water service coming in from the municipal water supply or from your well, the copper underground pipe was in fact your grounding system or part of the grounding system. But that's never meant to be applied for gas piping. And even in older homes where that's metal service line coming from the main the street, there is a dielectric barrier between where your gas line comes up out of the ground to your meter before it goes into the house. So the gas piping by code should never be used as a grounding electrode. So if you're getting that kind of message from an electrical person, they're ignorant of the requirements for grounding of the house, because gas piping has never been permitted to be used as a grounding system.
Okay.
Point number one. Point number two is that, again, we're not grounding the gas piping system. So the only thing that's grounded in your house is your electrical service, and that connects to all the grounding electrodes. What we are doing with the gas piping, as well as the electrical service and the copper water pipes and your satellite dish and your coax cable, is we're bonding these things together so that they get electrified in unison when there's a power surge or when there's a lightning strike. And so we're bonding the gas piping to the electrical service so that we have a common ground and we only have one ground for the building. And so the bonding is what we're asking for, not the grounding. And the bonding for CSST has been in the codes since 2009. So again, this person is the ignorant one trying to make you feel bad. But the reality is that it's been a fuel gas code requirement since 2009.
Bob, real quick, I know it's a little past 8. Can you explain for everybody briefly the difference between bonding and grounding?
Okay, so as I just quickly said, grounding is we're trying to get this energy from, so in the case of a fault in the house, we're trying to make sure that the power goes to ground so it doesn't arc to other pathways, or there's a circuit breaker in your house to cut off the flow of power. But the reference point is Earth, good old Mother Earth. And so if we have short circuits or ground faults, we want to be sure that the circuit breakers have a common frame of reference. Same thing for spurious currents. You worry about stray currents and everything else. If we all have a common ground reference point, then we eliminate the ability for these stray currents to cause sort of like a tickling effect when you touch a faucet or something. Now, that's grounding. All these other pathways, you have many metal pathways to ground: heating and cooling ducts, copper water pipe, satellite dish, coax cable. And so we don't want arcing between these pathways. And so we tried to put them all at the same voltage potential. So we sort of cross connect all the metal pathways to ground with a bonding conductor so that when they get energized, all the pathways get energized at the same rate and to the same voltage potential. And that basically prevents arcing between pathways. If we put the CSST on top of the heating and cooling duct, if they're at different voltage potential, the arc wants to jump. and that causes potential for a burn through or a fire. So bonding puts all the pathways at a common potential, and we have a common ground, and it eliminates all these possibilities from initiating damage and or fires in the house. But so bonding is the cross connecting, grounding is the single connection with Mother Earth. And that's only for the electrical service.
Thank you.
Thank you. Well, I think it's been a great seminar. We would love to have you back to go further into other subjects concerning CSST
Yep.
in the future.
Yep.
And I want to thank you for your time. And
Yep.
I'm going to be ending the seminar now.
Thank you, Bob. Appreciate it.
Thanks,
Oh,
Bob.
you're welcome.
Good week.
You have